Hello everyone. Previous lecture we have studied the concept related with the chapter straight line, and in that we see some important standard forms related with the line. Now in today's lecture also we are going to see some standard forms, and here first is here double intercept form. Okay, so we consider one line. Suppose our line is L1. This line L1 touches the x and y axis both. Here the line L1 touch the x axis at point A of A0 and on y axis at B of 0B. Here everyone knows here A is the x intercept and here y is the B is the small b is the y intercept. So related with this intercept, that is A and B, which are the intercept of x and y respectively, here we have a form, that is here we have a equation of a line related with this form, and is here x upon A plus y upon B is equal to 1. Here remember we consider point P which is having coordinates x and y, and using these x and y we define this form, and here is x upon A plus y upon B is equal to 1, and this is called the double intercept form. Okay, so in today's lecture we are going to see some important examples related with this double intercept form. Okay, so we go with some important examples. Let's go with first one. Find the x and y intercepts, capital X and capital Y intercepts of the following lines. Okay, here in the first given x upon 3 plus y upon 2 is equal to 1. Okay, here in this example we have to find the x and y intercept using this equation of line. Here everyone knows this line is in the form here x upon A plus y upon B is equal to 1, and here we know A is called x intercept and y is called, or here B is called y intercept. Okay, so here we know the double intercept form, here is x upon A plus y upon B is equal to 1. If we compare these two equations, here we get x and y intercept. Here x intercept is A and here A is 3. Here A is 3. Okay, then here y intercept here is B. If we compare these two, here we get y as 2, B as 2. Okay, so we find the x and y intercept. Let's go with next example. Here in second given 3x upon 2 plus 2y upon 3 equal to 1. Here again we have to find x and y intercept. Okay, firstly we consider given equation again. Consider here 3x upon 2 plus 2y upon 3 is equal to 1. We know our double intercept form, and here we consider x upon A plus y upon B is equal to 1. Here in numerator is x, here is y. Okay, so in numerator we want only x and y, not any constant. Okay, so here we divide numerator and denominator both by 3, so we get here x upon 2 by 3, and in next we divide numerator and denominator both by 2, here we get y upon 3 by 2 is equal to 1. Now we know this is in the form x upon a plus y upon b is equal to 1. Okay, so here x-intercept is equal to a, and a is 2 upon 3, and y-intercept here is b, and b is 3 by 2. Okay, so a very simple example it is, in that we define the intercepts only, that is intercept of x and y axis. Let us see one more example related with this form. Example, find the equation of line. Find the equation of line making intercepts 3 and 6 on coordinate axis. Okay, here in this example x and y intercept are given. Let us consider here x intercept is 3, y intercept is 6, and we know here double intercept form, and using this form we find equation of line. Okay, so here given x intercept, let us consider this as a, suppose this a is 3. Then here y intercept, suppose this y intercept is b, and here b is 6. Okay, so by using double intercept form, here we get, okay, firstly we consider our form. Your form is x upon a plus y upon b is equal to 1. Let's replace a and b in this equation. So here we get x upon, we know a is 3, plus y upon, we know b is 6, and this is equal to 1. If we calculate this part, here we get 2x upon 6 plus y upon 6 is equal to 1. Okay, then using this form or using this part, here we get 2x plus y upon 6 is equal to 1. And lastly, here we get 2x plus y is equal to 6. And this is the required equation of the line. So using our double intercept form, we find equation of line. This is required equation of line. So very interesting part it is, and very simple examples in that. Okay, so this is our one of the standard form of the line. Let's go with our next standard form, and in that we consider normal, that is we consider normal form. Okay, so we go with this part, normal form. And to define this normal form, we consider one figure. Okay, let us consider the coordinate axis, that is x and y axis. Okay, this is our x-axis, here is our x-axis, here is y-axis, here origin is at O. Let us consider one line L. Suppose this line is like this, this line is L. Here in this normal form, we consider one normal, that is we consider one perpendicular, and here perpendicular is from origin to the line. Perpendicular is from origin to line like this. Okay, suppose this segment is ON and here ON is a perpendicular to the line L. ON is perpendicular to the line L. Okay. Let here length of this ON, that is length of this segment, here is P. If this length is P, then here angle generate in between the ON and X axis here is X. We consider the positive direction of X axis to define this angle alpha. If it is alpha, then here coordinates of this N are here P cos alpha and P sin alpha. Remember this part. Here coordinates of N are P cos alpha and P sin alpha. So using these things, we define the normal form, and using normal form, we find this equation of line. And to find the equation of line, here we have an equation. Here x cos alpha plus y sin alpha is equal to P. And here remember, P is the length of this segment ON. P is the length of this segment ON. Okay, so this is our normal form. Let us see some important examples related with this normal form. Okay, so example here given the perpendicular drawn from the origin to a line has length 5 and perpendicular max angle of 30 degree with positive direction of x-axis, find the equation of line. Find the equation of line. Okay, so here example is given, and very simple example it is. Here remember, given the perpendicular drawn from the origin to a line has length 5. Has length 5 means here P is given, and here P is 5, that is the length of the perpendicular is the 5. Here remember, this N is also called as a foot of perpendicular. Is also called as foot of perpendicular. Here also given the perpendicular max angle of 30 degree. That is, here alpha is given and here alpha is of 30 degree. Okay, so here I write given things first. Here given P is equal to 5. Here given alpha is equal to 30 degree, and by using our normal form we find equation of line. So by using normal form, here remember normal form is having x cos alpha plus y sin alpha is equal to P. Let's replace alpha and P in this given form. Here x into cos of alpha is 30 degree plus y into sine of 30 degree is equal to, we know length of the perpendicular is 5, so this is equal to 5. Therefore, here x into, here everyone knows cos of 30 degree is here root 3 by 2 plus y into sine of 30 degree is here 1 upon 2 is equal to 5. Then here we get root 3x plus y, this divided by 2 equal to 5. And in last, here we get root 3x plus y is equal to 10, and this is the required equation of the line. This is required equation of line. Okay, so very simple example it is. Directly by using the given things and by using the normal form, we find the equation of line. Let us see one more example. Here in second, given if n of 3 minus 4 is the foot of perpendicular drawn from the origin to line L, find equation of line L. Find equation of line L. Okay. Again, one example is given. Very simple example it is. Here directly the foot of perpendicular is given. N is given, and we know here foot of perpendicular is drawn from the origin, or is this perpendicular drawn from the origin to the line, and on the line we have a foot of perpendicular. So to define this part, we consider one figure. Okay, here point n of 3 minus 4 is given. Everyone knows this point is in fourth quadrant. This is in fourth quadrant. So we consider fourth quadrant here. This is our x-axis. Here is y-axis. This is negative side of y-axis. Here is negative side of x-axis. Here origin is at O. Suppose here our foot of perpendicular n is given and is having coordinates 3 minus 4. Our line L passing through this n. Okay, like this. This is our line L. Okay, and here we consider perpendicular drawn from the origin to the line. So this n is the foot of perpendicular. Okay, so using these parts, we have to find the equation of this line L. Okay, so very simple part it is. Firstly, here we find slope of the segment ON, slope of this ON. Okay, we directly go with this part. Here, slope of ON is, here remember, if in our line we have 2 points and having coordinates here x1 y1 and x2 y2, then the slope of this line is y2 minus y1 upon x2 minus x1. So using this part, we find slope of ON. Okay, here slope of ON is equal to, here remember, y2 minus y1 upon x2 minus x1. Let us consider here coordinates of origin as here x1 y1 and are 0 0, and here coordinates of this n as x2 y2 and are 3 minus 4. Okay, so here we get y2 is a minus 4 minus here y1 is 0, then this divided by here x2 is 3 minus x1 is 0. So this is equal to We know minus 4 minus 0 is minus 4 and 3 minus 0 is 3. So minus 4 by 3 is the slope of the segment ON. Okay. Now here we know this ON is perpendicular to the line L. If it is perpendicular, we find here slope of line L. Okay. So here I write since ON is perpendicular. ON is perpendicular to line L. Therefore, here slope of L is here minus 1 upon slope of ON, that is minus 4 by 3, and here we get 3 upon 4 only. Here slope of line L is 3 upon 4. Now we go with our next part. Here we know slope of line L. Here we know the point which is on the line L. So by using slope point form, we find equation of line. So by using slope point form, okay, here we know slope point form is having y minus y1 is equal to m into x minus x1. Therefore, here y minus, let us consider coordinates of point n as x1, y1. Here x1 is 3, y1 is minus 4. So here we replace y1 by using minus 4. We know m is, that is slope of line L is 3 by 4. So here 3 by 4 into bracket x minus x1 is 3. Therefore, here we get y plus 4 is equal to 3 upon 4 into bracket x minus 3. Then here we get 4 into bracket y plus 4 is equal to 3 into bracket x minus 3. Let's multiply this first bracket by 4. If we multiply, we get 4y plus 16 equal to, then we multiply second bracket by 3, we get 3x minus 9, and in last here we get 3x minus 4y, then minus 25 is equal to 0, and this is the required equation of the line. This is the required equation of the line. So, a very simple example it is, directly by using our foot of perpendicular, using the here slope point form, we find the equation of the line. Okay. So, in today's lecture, we see two standard forms. First is here double intercept form, then we see the normal form, and we see some important examples related with these forms. Thank you.